Hello, this is Geometry Notes 3.5, Proving Lines Parallel. Make sure you put your name at the top of the page and your hour. Let's say it's B4. I want to recap from 3.2, the corresponding angles postulate, the alternate interior angles theorem, the consecutive interior angles theorem, and the alternate exterior angles theorem. Each one of those talks about if you have parallel lines being cut by a transversal, then we have a certain relationship between pairs of angles. Today in 3.5, we're going to reverse that order, switch the if and then around. Let's look at the converse of the corresponding angles postulate. And what that says is if you have two lines in a plane, they're not necessarily parallel. If they're cut by a transversal so that corresponding angles are congruent, then we can conclude that the two lines are parallel. So let's look at example 1. Remember, when you are doing these items, I always want you to, with your red pen, mark up your lines and then shade in between. So make sure that your 4 pictures are marked appropriately. Pause if you need to. It allows us to see the interior and the exterior angles. The interior angles will be in the red mark. For example 1, if angle 1 is congruent to angle 6, note that those are corresponding angles. If those are congruent, then we can conclude by the converse of the corresponding angles postulate that line M is parallel to line N. Let's move on to example 2. And in example 2, we are given angle 4 and angle 7 are congruent. That's another pair of corresponding angles. And since the if says that those are congruent, now we can conclude that M is parallel to N. Number 3 says that if angle 2 and angle 5 are congruent, now that's a pair of corresponding angles. Since that pair is congruent, now we can conclude by the converse of the corresponding angles postulate that those lines are parallel. And finally, another pair of corresponding angles is congruent, angle 3 and angle 8 in a different problem. Since those are congruent, we can conclude that lines M and N are parallel. Moving on to our next theorem, the converse of the alternate exterior angles theorem says that if we have a pair of alternate exterior angles congruent, then the lines are parallel. So looking at example 1 and example 2, mark up those pictures so that we have the red pen marks on M and N and color in between them. Pause if you need to. So your pictures should be marked accordingly. And now let's look at example 1. If I have a pair of alternate exterior angles, so let's say that 1 and 8 are congruent because those are a pair of alternate exterior angles. So if angle 1 is congruent to angle 8, then our conclusion is that the two lines are parallel. Let's look at example 2. Identify another pair of alternate exterior angles. That would be 2 and 7. So if angle 2 is congruent to angle 7, then we can conclude that line M is parallel to line N. The converse of the consecutive interior angles theorem says that if you have a pair of consecutive interior angles supplementary, then the lines are parallel. So mark up your pictures. So go ahead and color M and N and in between them. And in example 2 also, pause if you need to. So your pictures are marked. Let's identify a pair of consecutive interior angles. That would be 4 and 6 is a pair. So if the measure of angle 4 plus the measure of angle 6 equals 180 degrees, then we can conclude that M is parallel to N. Identify another pair of consecutive interior angles. How about 3 and 5? So if the measure of angle 3 plus the measure of angle 5 is 180 degrees, then we can conclude that line M is parallel to line N. And lastly is the converse of the alternate interior angles theorem. It says that if you have a pair of alternate interior angles congruent, then you can conclude that the lines are parallel. So go ahead and mark up those pictures with their red lines. And my pictures are marked up. So let's identify the pair of alternate interior angles. Let's identify 4 and 5 being a pair of alternate interior angles. So if I'm given that 4 is congruent to angle 5, then I can conclude by the converse of the alternate interior angles theorem that line M is parallel to line N. And another pair of alternate interior angles, another example. If I'm given this picture and I'm given that angle 3 is congruent to angle 6, then I can conclude by the converse of the alternate interior angles theorem that line M is parallel to line N. Now let's move on to some examples. Example 1 says that given that angle 4 is congruent to angle 7, determine which lines are parallel. Well, first of all, we're just going to cross out line N because that doesn't have anything to do with where 4 and 7 are. So go ahead and mark up the lines L and M with your red pen. And we can identify now, looking at this picture, that 4 and 7 are alternate exterior angles. So my conclusion is line L is parallel to line M, and the justification is the converse of the alternate exterior angle theorem. Because we know that those angles are congruent, therefore the lines must be parallel. Now in example 2, we are given that angle 2 and 3 are congruent. So go ahead and mark off N, and then with your red pen, go ahead and mark the 2 lines L and M and identify the transversal. So from our red pen marks, we can see that 2 and 3 are alternate interior angles. So our justification is by the converse of the alternate interior angle theorem that the lines L and M are parallel. Number 3 says given that the measure of 4 and 5 add to 180, so that means that line L doesn't matter in this problem. So go ahead and mark up M and N with your red pen marks. Now we can see that 4 and 5 are consecutive interior angles. So therefore, since they add to 180, they're supplementary, line M is parallel to line N. So that would be by the converse of the consecutive, that's consecutive, interior angles theorem. In example 4, we're given that angle 1 is congruent to angle 3, so we can get rid of line N, mark up L and M. So we see that 1 and 3 are corresponding angles. So therefore, since those two angles are congruent, we can conclude that line L is parallel to line M by the converse of the corresponding angles postulate. Remember that the corresponding angles postulate is the only one with the postulate, so the converse also will be the only one that has the postulate. Last example says that if angle 6 is 3x and the measure of angle 4 is 2x plus 45, find x so that the lines are parallel. The so that means that this is going to be a converse, meaning that the end will be parallel lines. So if the end is parallel lines, that means that we're dealing with the converse of one of the problems. So let's go ahead and get rid of line L and just work with M and N. You can see here that 5 and 6 are vertical angles. So by the vertical angle theorem, we know that this is 3x. I'm just going to write down VAT for vertical angle theorem, but on a test or homework, write down vertical angle theorem. And now we can identify that 4 and 5 are corresponding angles. So by the converse of the corresponding angles postulate, so corresponding angles postulate, we know that their sum is 180. So we have 2x plus 45 plus 3x add up to 180 degrees. So that's 5x plus 45 equals 180. Subtract 45 from both sides. So 180 minus 45 is 135. Divide both sides by 5 and you get 27. So x is 27. And that's the end of our lesson.